Today we'll have a lesson on strength of materials. So let us take the topic stress and strain. No engineering material is perfectly rigid. It undergoes deformation when external load is applied. While undergoing deformation, the particles of the material exert resisting force. This resisting force, which is offered by the particles of the material when an external load is applied, is called stress. So, stress is the resistance force per unit area. It is the resistance force per unit area. Mathematically, it is defined as the force per unit area, and it is denoted by the letter sigma. So sigma is equal to P by A, where the unit is in Newton per mm square. P is the load acting on the member and A is the cross-sectional area. The other derived units are Pascal. 1 Pascal is 1 Newton per meter square, and 1 megapascal is 1 Newton per mm square. There are different types of stresses depending on the type of forces acting on the members. So let us consider a member axially loaded which is subjected to tensile force. You can see that there are two equal and opposite pulls on and which is acting perpendicular to the cross section of the member. So this will induce a resistance force inside the member. Because of this external force, that resistance force will be opposite to this direction of the applied load. So if you take a cross section near the end, the resistance force will be in the opposite direction, and these are the stresses developed perpendicular to the cross sectional area, and these stresses are called as the tensile stresses. So if you take a cross section at this end, so the stresses will be developed in this direction. So, and then next is a compressive force. If there is a compressive force, the stresses will be developed in this direction. So this is nothing but the compressive stresses. So similarly, this side it is developed in the opposite direction. So these are the tensile stresses and the compressive stresses. So what is shear stress? So when there is a shear force, the shear force is a force which is acting parallel to the cross-sectional area. So if you take this area, so here the force is parallel to this area. So the stresses developed in this case is called as the shear stresses. The shear stresses are parallel to the cross-sectional area. Therefore, there are three types of stresses. One is the tensile stress, the other one is the compressive stress, and the shear stress. So tensile stress is due to the tensile force, and the compressive stresses are due to compressive force, and the shear stresses are developed due to shear force. And these two stresses, the tensile stress and the compressive stress, are called as the direct stresses, whereas the shear stress is called as a tangential stress. So when we come to strain, so what is strain? Strain is when load is acting on a member, there will be deformation, and strain is nothing but the measurement of deformation produced by the application of the external forces. So in case of tensile force, say like this, in this example, where there is a tensile force, the member will elongate. So this is the extra length. This is the additional increase in length due to the application of this force P, tensile force P. This change in length per unit length is nothing but the strain epsilon. So the length of the member is L naught, whereas epsilon is the strain, which is given by delta L by L naught. Delta L is a change in length and L naught is its original length. So this strain is called as a linear strain. Similarly, if there is a compression force, there will be reduction in the length of the member, and here the change in length is the reduction in the length of the member. Change in length towards original length is again the compressive strain, and it is called as compressive strain. So when you see this example, so here the member is subjected to tensile force P, and because of this there is increase in length, whereas there is decrease in diameter. You can see this, there is decrease in diameter. That means there is a lateral strain which is happening here. Lateral strain is defined as change in the lateral dimension per unit lateral dimension. So in this case there is a linear strain, and in this case there is linear strain and the lateral strain. Linear strain is nothing but the increase in the length of the member. Lateral strain is nothing but there is reduction in the diameter of this member. So this is an example for a shear strain. You consider an element A, B, C, D which is subjected to shear stresses on B and on the face AB and CD as shown here. So because of this there will be an angular displacement. So this is the angular displacement phi, and this deformation is expressed in terms of angular displacement, and it is expressed as tangent of the angle of deformation, and this is called as the shear stress. So what is linear strain? Linear strain is the ratio of change in length to original length. So it is a ratio of change in length to original length, whereas lateral strain is change in the ratio of the ratio of change in lateral dimension to original lateral dimension. It is also a ratio. It is a ratio of change in lateral dimension to original lateral dimension. So, and shear strain is expressed as tangent of angle of deformation.